Alright, so in this video, we will be talking about a polynomial function. So basically, we'll just um, focus on the illustration or how to illustrate a polynomial function and how it looks like. So polynomial function, it is it's a uh, wide set of algebraic equation with some important requirements for it to be a polynomial function. So usually it's denoted by f of x or sometimes p of x as polynomial function. Um, Even if you just say 3x, 3x is alone is a polynomial function with only one term. Let's say p of x is equal to negative 2x squared plus 1/2 x minus 4/3, for example. So although it consists of fractions for the numerical coefficient, it is still a polynomial function. So this is, by the way, this is the numerical coefficient, this is the literal coefficient, and we have this as the exponent. And let's have some more examples. Let's say a 9x cubed minus x plus 8. So that's a cubic equation, which is actually part of the polynomial function. So for this to be a polynomial function, the exponents must be integers, meaning there is no fraction for the exponent of the the literal coefficients or the variable. So that means you cannot do something like this. P of x equals, let's say, 3x to the power of 1/2 plus 2. So this is not a polynomial function because it has a fractional exponent, or even let's say a square root or any root. Let's say, because this x to the power of 1/2 is the same as 3 times square root of x, because x to the power of 1/2 is just the same as square root of the variable. So that's why you cannot put some radical sign in the variable for it to be a polynomial function. Also, there is no negative exponent. You cannot do it this way. Let's say 6x to the power of negative 2 plus, let's say, 8x minus 3, for example. So you cannot have this because that is a violation for a function or a polynomial to be a polynomial function. So it's just an algebraic expression, but it's not a polynomial function. Also, you cannot have a variable at the bottom. Let's say the p of x equals 2 over x squared minus 4x plus 1/3, for example. So you cannot have this because it will violate the definition of a polynomial function. It should not be a variable at the bottom. All right, so the graph of a polynomial function, we'll have some more details about that in some other videos, but we can picture out how it looks like based on the given. Let's say, for example, you have negative 3x to the 4th power plus 2x minus 5 x cubed plus 5x squared plus 2x minus 1, for example. So by looking at the leading coefficient, by the way, this is the leading coefficient because it has it has the highest exponent of its literal coefficient. So we have 4. And so you can imagine it in a graph that the graph of this polynomial function is crossing the x-axis 4 times because it's x to the power of 4. So it's somewhere something like like this. So 1, 2, 3, 4. So there are 4 intersections of x, 1, 2, 3, and 4. So that means If the graph is like this, that means it's to the power of 4 with its leading coefficient. If it's negative on its numerical coefficient with its leading coefficient, so the graph starts from the bottom. So it starts from here at the bottom and going upwards and alternating. Now, if it's positive, so so let's say it's like this. P of x equals 2x to the fourth plus plus x. All right, so plus x minus 5. So for example, like that, the leading coefficient is positive, and it's x to the power of 4. That means it's from the top and going to the bottom, and it's going to cross the x-axis 4 times. It's like this: 1, 2, 3, 4. So 1, 2, 3, and 4. So it's from the top and going to the bottom and alternating. So that is how it looks like if you're going to graph that. But for sure, we're going to have some of the details on how to graph a polynomial function in another video.